Welcome to week 5. We're going to be doing some practice with scientific notation today. So we are on page 33 in your Unit 7 packet, and we're going to start right away. Number 1 says the table contains 7 measurements written in decimal and scientific notation. Complete the table so that each measurement is written in both decimal and scientific notation, and then rank the measurements in order of size. 1 is the smallest number, and 7 is the largest. So this gives us this first one in scientific notation. What is this? Is a decimal. So you guys remember that when we have this negative sign here, that it means we're going to take the decimal from where it is and go 2 to the left. So if I do that, 1, 2, the decimal form would be 0.01, and this is in meters, so this is going to be in meters. This next one, I'd have to bring it over 3 to make it into a 4. And this is a really small number, so this would be times 10 to the negative 3. This 200, if I move this over, right now it's right here, and I move it over 2 places, this would be 2 times 10 to the second power. Remember, larger numbers are written with positive exponents, and really small numbers are written with negative exponents. So this one, right now, the decimal's right here, and this is a positive 5, so we'd be moving we'd be moving the decimal point that's after the 8, 5 units to the right. So 8, and then 1, 2, 3, 4, 5. And I just add my zeros where appropriate, and again, this is in meters, so I'm just going to leave that like that. I've got another 4, and I'm going to have to move this up 1, 2, 3, 4, 5, 6, 7 times to make this into a scientific notation. Nope, I should have written meters here as well. 40 would be 4 times 10 to the first. I only have to move it once. Negative 4 means I have to take this decimal from where it is and move it 4 times to the left. So if I did that, it would look like this. So now I'm going to be ranking them from largest to smallest. When I take a look at that, what helps me... Oh, sorry, yawn. What helps me the most is taking a look at the exponents. So if I'm looking for the smallest number, I'm looking for a number with the smallest negative. So negative 2, well, negative 3 is smaller than negative 2, and negative 4 is even smaller than that. So this would be my smallest number, then my next smallest, and third smallest. And now all I have left are positive exponents. So the smallest number here would be 4, and then this would be the 5th number, and the 6th number, which makes this one the 7th, or the largest number. All right, next thing, identify the greater number in each pair of numbers. Justify your reasoning. So if I'm comparing these two, first thing I notice is that they're exponents. This one is a positive 2, and this one's a positive 3. So this one would create a bigger expanded form, right? Because I'd be moving this decimal more times to the right. In this one, they're both -1, so the only thing that's left to compare is the number out front. And in this case, this one is bigger, so I'm gonna say it that way. In this one, it's kind of hard to compare these two, so I can make this into scientific notation by bringing this up 6 times. So 8.7 times 10 to the 6th, and now it's much easier to compare these two. I also could have taken this and gone 3 times, so 1, 2, 3, like this, and compared these two. Either way, we know that this one is the bigger number. And same thing here. I could change this over by going 3 to the left, so, or take this one and show this in scientific notation. That would have been 3 to the left. Notice these are both -3s, and if I'm going to take a look at these two numbers, this one would be the bigger of the two numbers. All right, so that's it for this one. Just comparing these and ranking these. All right, for 6 and 7, they gave us a table on the right-hand side, which talks about the different volumes for Venus, Earth, and Mars. It says, about how many times larger is Venus than Mars? So if I look, Venus is larger than Mars. If I want to find out how many times larger, I have to divide. So 9.4 times 10 to the 11th divided by 1.6 times 10 to the 11th. And you could simply put that into your calculator if you wanted to. 9.4 divided by 1.6. And I get 5.875 times 10 to the 11th. Oh, no, not times 10 to the 11th, because when I divide those, I subtract. So that would really go away. It'd be times 10 to the 0 power, which is the same thing as 1. So it's 5.875 times larger. How many times larger is Earth than Mars? Well, let's take 1.1 times 10 to the 12th and divide by 1.6 times 10 to the 11th. And if I divide 1.1 by 1.6, I get 0.6875 times 10 to the 12 minus 11 is 1. So, and that's good because this number is not between 1 and 0, so this is not written in scientific notation. And I know that if I was to take this times 10 to the first power, I'd have to move this over 1. So either way, this works out. So it's 6.875 times larger. Next question. There are this many spectators in a stadium watching a football game, and in a theater there are this many people watching a concert. Which venue has more people, and by how many? Well, if I want to compare these two, oh goodness, sorry for all the yawning. It's easier to do that if they are in the same form. So let's take this and turn this into scientific notation. 1.15 times 10 to the, we had to move that 3 times. So I know that if I compare these two, which venue has more people? Well, we can see from this that it's going to be the football game, football stadium. And by how many people? Well, we'd have to take the first number and subtract this one. And remember that when we subtract, these need to be the same exponent. So I'm going to have to change this into something times 10 to the 4th. And if I make this number bigger, that means that this one has to become smaller. So this would become smaller by 1. So 1.15. So if I take 5.816 times 10 to the 4th, and I subtract this, what is that equal to? So 5.816 minus 5.816 minus 0.115. I get 5.701 times 10 to the 4th. So by how many people? By this many people. If you wanted to, you could turn that into a standard notation, make that into a regular number. I'd have to move 4 units to the right. So 57010 by 57,000 people. An actor has this many likes on Facebook and this many followers on Twitter. About how many fans does the actor have? So on these two social media platforms at any rate. So I'd have to add those two together. So again, let's turn this into a number that's in scientific notation. So 7.5126 times 10 to the, we had to move this 1, 2, 3, 4 times. And this is already 10 to the 4th. That's great. Makes it a little bit easier when I add them together. So I'm going to be adding these two. And if I take 7.5126 and add 8.58, I get 16.0926 times 10 to the fourth. This is not a number that's in scientific notation because this needs to be between 1 and 0. So I'm going to change this by moving it over 1. So if I make this number smaller, this one goes bigger by 1. So that's about how many fans he has. All right, in the answers below, you're going to either write equals, less than, or greater than. So if I compare these, I'm going to have to kind of work these out before I can do anything. These two are being multiplied, so I multiply what's out front, and I add the exponents. And when I divide out front and subtract the exponents. So which one of these is bigger? This one, only because these exponents are the same, so really all there is that we're comparing is the 9 and the 3 out front. And this one, there's nothing that I have to do on the left, there's only on the right. I have to change this into a 4 times, and I'm still going to subtract, but this time I'll do 7 minus 11, which would be -4. So which one of these is the bigger number? Well, this one, because this exponent is closer to 0, so that makes this a smaller number. When I add, they need to be the same exponent up here. So since these are, I can just add the number out front. But this 12 isn't between 0 and 1, so I'm going to make this 1.2. Since I made this a smaller number, this one becomes bigger. And now I can compare these two because there's nothing that I can have to do to this one. And 10 to the 5th is larger than 10 to the 4th. So that one's going to be the bigger number. Nothing to do here on the left, except that this is all scientific notation stuff. So if I wanted to, I could change this into 1 times 10 to the 1, 2, 3, 4, 5, 6. And then these two, these are 10 to the 5th. So that's great because I can keep that and just subtract the 2 that are up front. So 1 times 10 to the 5th. If I'm comparing these two, this one's the bigger number. Number 14. The world population is about 7 billion. There are this many ants for every human on the planet. So for every one person, and there are this many of us, there are this many ants. So how many ants are there in the world? Well, we'd have to multiply those two. So if I multiply 7 times 10 to the 9th by 4.6, oops, close that before I meant to, times 10 to the 7th, then I'd have to multiply these two and multiply 7 times 4.6 and get 32.2 times 10 to the, add these two, you get 16. This is not a number between 1 and 10, so I'm going to change this to 3.22. And I made this number smaller, so the exponent's going to go larger by 1. So how many ants are in the world? This many ants. 10 to the 17th, that's a really, really, really big number. Number 15, use this formula. P equals V squared over R to calculate the value of P when V is this number. So we're going to just replace this number right here. So we've got 6 times 10 to the 6th, and that's being squared because this V is being squared, over 7.2, the R value, times 10 to the 8th. Well, let's take care of this square thing that's happening first here. So here's the question. Do you square just this thing, or do you have to square both? We've talked about this before, but just as a reminder, if I had something like 3a and I squared it, well, 3a would be 3a times 3a. And 3 times 3 is 9, and a times a is a squared. 3 squared is 9, like this. So yeah, the answer is you have to square both. So I would square 6 and get 36, because 6 times 6 is 36. And then for this one, if I have a power raised to a power, I multiply those two, just as a reminder. So 6 times 2 is 12. And there's nothing to do here in the bottom, so I'm just going to rewrite this in. These are being divided, so I'm going to divide these front terms. 36 divided by 7.2. I get 5. And now with these two, I subtract the exponents, so times 10 to the 4th. So this is the value of p when I put those two in. Now it's asking us to find the value of this. So again, I have a division question. If I take 2.1 and I divide by 7, I get 0.3 times, and I subtract the two exponents here, 10 to the 57th. Now, this is not a number between 1 and 10, so I'm going to move it over 1. But now I just made this number bigger, so the exponent this time goes smaller. Which one of the numbers below has the same value as this? Well, let's talk about this. Is this the same thing as this, or this, or whatever? So let's go through. With this one, this number out front is not written as a number between 1 and 10, so I'd have to make it smaller. If I make this smaller, then this exponent has to become bigger by 1, a number closer to 0. So this one is the same value. Is this? No. 3 and -3, not the same thing. Is this one? Well, if I wrote this as a number in scientific notation, I'd have 3.5 times 10 to the, I had to move this 1, 2, 3, 4 times, and it was a really small number, so it's a negative, so no, these two aren't the same either. This, if I wrote it in scientific notation, I'd have to bring this up here 3 times, and it's a bigger number, so +3. These two are not the same, only this first one here has the same value. How many 50-cent burgers can you buy for $1 million? Okay, this is an interesting question. How many 50-cent burgers can you buy for $1 million? So if you have $1 million, so if you just think about this question, right? If, say you had like 50-cent burgers and you had $20 to spend, couldn't you take 20 and divide by 50 to figure 50 cents to figure out how much it is? It's the same thing here. It's just this is scientific notation. So if you have $1 million and divide by 50 cents, well, 50 cents is the same thing as 5 times 10 to the, if I moved this over, it'd be -1. So I can do the same thing here that we've been doing, if it makes it a little bit easier. So 1 divided by 5 is 0.2. And I subtract these two, except that when I subtract 6 minus -1, that's like 6 plus 1, so I get 7. Now I'd have to move this over 1. So I'm making this into a bigger number, which means this one becomes a smaller number. So 2 times 10 to the 6th, or if you really wanted to see what this looks like, if I move it 6 times, that would be 2 million burgers, which is kind of easy to figure out, right? If we go back to this question, if it's 20 and they're 50 cents, well, 20 divided by 50 is 40. It's going to be twice as much as you have. All right, last question here for on this page. We're on page 35. How many years does it take to earn $1 million if you're paid $30 an hour and work 35 hours a week and for 50 weeks a year? Oh boy, so how much does that mean that you earn each year? So it'd be $30 an hour times 35 hours a week. Well, 30 times 35, that'd be 1,050. And if you work 50 weeks a year, times 50, that would be 52,500. So how many years would it take to earn 1 million? And we already know 1 million is this. Well, let's take that 1 million. And this number, we're going to turn it into scientific notation, 5.25 times 10 to the 1, 2, 3, 4. So if I divide 1 by 5.25, oh, that's not a yummy number. How about we just take and do this in standard notation instead? $1 million divided by 52500. You could do it the other way, but I'm just going to do it this way because it probably makes sense to more people, because the other number is really messy. You get approximately 19 years. It's just a little bit over 19. 19.0476, blah, 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 blah. So we're going to say approximately 19 years. All right, last page. Determine the product of these two things. Pick the correct choice. All right, so I would again turn this into a scientific notation. I'm going to have to move this one 2 to the left. And then if I take this and multiply by this, I would multiply the two numbers out front. So 8.005 times 2, I get 16.01 times, and oh, I don't know why I wrote that. That's supposed to be 10 to the 6th, the same number as right here. That was weird. Sorry about that. Okay, so if I take these two and I add those exponents, times 10 to the 8th. So are these two matching? Well, actually, what we need to do now is this number 16 is not between 0 and 1, so 1.601 times, I made this one smaller, so this one's going to be bigger by 1. So not this one, not this one, not this one. Here we go. Okay, 3 left. Determine the sum of these two things. I'm going to turn this into scientific notation. 3 times 10 to the 4th plus 5 times 10 to the 6th. Remember that these two, in order to add them, need to be the same. So I need to bring this up to 10 to the 6th. And if I make this bigger by 3, or 2, I have to make this smaller by 2. So 0.03 plus 5 times 10 to the 6th. Now that they're both times 10 to the 6th, I can add the two numbers out front, 5.03 times, and I keep the 10 to the 6th. The difference means that I subtract, so I'm going to have to subtract whatever this is. 8 times 10 to the 1, 2, 3, 4, negative 4. Minus, because it's difference, that means subtract, 3 times 10 to the negative 5. I need these two to be the same. This is the larger exponent, so I'm going to change this one. So if I make this one into a bigger number, then this one has to become smaller. So 8 times 10 to the negative 4 minus 0.3. So 8 minus 0.3 would be 7.7 times 10 to the negative 4. And determine the quotient. So difference is subtract, quotient is divide. 32 billion. Well, 32 billion. Here's 32,000, 32 million, 32 billion. So 3.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I take 3.2 times 10 to the 10th and divide by 4 times 10 to the 7th, well, 3.2 divided by 4 is 0.08. And if I subtract these two, 10 minus 7 is 3. Nearly there. It's just, oh, I wrote that wrong again. Man, I'm having a hard time with that today. Moving things around. There we go. This is not a number between 1 and 10. So I need to move this over 1. I'm making this into a bigger number. So this one becomes a smaller number. And that's it. That's just some practice with all the things that we've been working on over the course of the last couple weeks. Next week, we're going to dive into something a little more complicated. So be prepared. Make sure you guys are sure how to do this stuff, and I will talk to you soon.